In this video, we are going to study about lesson 2.10, the mean value theorem. Specifically, we will see that how to explain the Rolle's theorem and how the Rolle's theorem can be applied to solve different kind of the questions. The objective is to describe the statement and the conditions of the Rolle's theorem, determine the existence of at least one point on the closed interval where the derivative of a function is 0. So let's understand what does the Rolle's theorem says. Rolle's theorem can be applied if the three conditions are fulfilled, and we will study about those three conditions. So the first condition is that if a function is given to you, then you must check if the function is continuous or not. And the function must be continuous in the closed interval. So if you are going to study about a function from a to b, then the function should be continuous in the closed interval a and b. What does it mean? It means that the point a and the last point b must be included in the graph. Okay. So the graph should be continuous everywhere at each and every point from A to B. There must be a continuity. There should not be any kind of hole which describes the discontinuity. Like for example, if this is the graph. Okay, so from point A till point B, if there is a hole, it means that this is the discontinuity. So you cannot apply the Rolle's theorem. If between A and B, okay, you will see any kind of the asymptote, okay, so there is a discontinuity over here. So you cannot apply the Rolle's theorem. Similarly, from A to B, if there is a discontinuity, if the lines are broken from A to B, anywhere in between or even in the starting point is not included, then the Rolle's theorem cannot be applied. So Rolle's theorem can be only applied if the function is continuous on the closed interval, means from A to B, it has to be continuous everywhere. Whatever the x value you put from A to B, you should give an answer. Undefined answers are not acceptable because they refer to a discontinuity. So now look at the figure 1. Okay, in the figure 1, the A point is included, the B point is included. And you can see a very smooth curve. There is no gaps or no holes in the graph. Similarly, in the figure B, the A point and the B points are included. Okay, are included in the graph, and there is no hole, no broken line, no asymptote in the graph. And the same you can see in the third graph also, that the A and the B points are included and there is no hole, jump discontinuity or asymptote in the graph. So you can say that the function is continuous on the closed interval. Now what is the second thing? The second thing is that you have to see if the function is differentiable or not. So the function should be differentiable in the open interval. So it should be differentiable on open interval. What does it mean that open interval? Why we need the differentiability in the open interval? Means don't make any kind of the slope of the tangent line on the edges of the graph. Okay, at the edges of the graph, no need to make any kind of the slope. So you have to make any kind of the slope, okay, any kind of the slope, or take the derivative in between A and B. So A and B are not included. You can read the graph anywhere, but don't read the graph at the edges of the graph. Now, there is one more thing. If you have a sharp turn, so let's suppose I have a graph of this, okay, so you know that this is the graph of the absolute value function. So over here at x equals to 0, you can see there is a sharp turn. So if you have in the graph a sharp turn, you can say that the left hand side and the right hand side are not equal to each other while taking the derivatives. So derivative of the right hand side is not equals to the derivative of the left hand side where at x equals to 0. So here is the A point and here is the B point. Although the graph is continuous, but at 0 you have a sharp turn and the graph is not differentiable at this point. Okay, similarly, if I have a graph like this, okay, so it is x to the power of 1 by 3 or any function like 2 by 3, if the graph is like that, again it is a sharp turn. Okay, if it is, let's suppose it's x to the power of 2 by 3, this is the function. So at x equals to 0, the graph has a sharp turn. So sharp turns indicates that the slope of the tangent line, if you create over here, it's undefined because it's a vertical line. So at this point, the graph is not differentiable. So important thing is that the function should be differentiable. And in order to understand graphically, the graph should have a smooth curve. Mostly it's a polynomial function. Or you should see that the given interval must be differentiable on the open interval. Now the third point, if the first point and the second point are fulfilled, then you will check the third point. The third point states, according to rules, that the height of the function at the initial and the terminal points or the last points should be equal to each other. So let's see the graph one. Okay, so the graph one, this is the graph one, A point. Okay, let's suppose the y value is 1. Okay, and this is the B point, and what is the height over here? Also the y value is 1. So if you check, so f of a, yani the value of y at A point is equals to the value of the y at the B point. Similarly in graph B, if I just show you, you can see, look, here is the A point. Okay, this is the height, and here is the B point, and if you check, the heights are equal to each other. Okay, similarly, here is the A point and here is the B point of the graph, and if you just see this one, the heights at the initial and the terminal points are equal to each other. So the heights, if the function is continuous, go to check second condition. If the function is differentiable, check the third condition, if the heights at the A and the B are equal to each other. If all the three conditions are fulfilled, you can apply the Rolle's theorem. And what does then Rolle's theorem says? Rolle's theorem says that if the function is continuous, differentiable, and f of a equals to f of b, then there will be some point where if you make the tangent line, the slope of the tangent line at that point will be equal to 0. So what is meant by the slope of tangent line? It means that the derivative is equals to 0. So this is what the rule says. Now, let's try to understand about it by solving few problems. So find the value of c satisfying the conclusion of Rolle's theorem for f of x equals to x cubed minus 3x squared plus 2x plus 2 on the interval of 0 and 1. Now let's check the first condition. The first condition, whether the function is continuous or not. So look at the function. The function name is polynomial function. Okay, it's polynomial function. Why it is polynomial function? We have studied in our previous classes, grade 9 and 10 and 11, that any equation which is written in one line means all the x's, all the x values or all the x terms are in the numerator, having the whole number power, then it is said to be a polynomial function. And in the polynomial function, the domain is all real numbers or negative infinity till positive infinity. What does it mean? It means you put any value of the x, whether a negative value or a positive value, or you put 0, you will get an answer. So you can say, because it is polynomial function, what is the conclusion? The conclusion is that the function is continuous on closed interval, that is 0 till 1. From where I get this closed interval? It's given in the question. Now second thing, check if it is differentiable or not. So what do? Take the derivative of the function. So the derivative of the function, by using the basic rules, x cube will change into 3x square. The derivative of minus 3x square, multiply minus 3 by 2, you will get minus 6. X from the derivative, subtract 1, so the power is 1, which we don't write. Plus derivative of 2x is 2. Derivative of 2 is 0, that's why I am not writing. Now again look at the function. The function is again a polynomial function because it has a power 2. Quadratic function, right? Quadratic function is a polynomial function. Now if it is a polynomial function, so again the domain is minus infinity till infinity, and we have to read the graph only between 0 and 1. So you can say the conclusion that it is differentiable. It is differentiable on closed interval, that is 0, 1. Now the third part. Set are the heights. This is the a point 0 and this is the b point 1. Are the y values or the height of the function at 0 and 1 equal or not? So what do? Find f of a. A means 0, so f of 0. Put this 0 in the original equation to get the value of y. So 0 cube minus 3 times 0 square plus 2 times 0 plus 2. So it will give you 2. Look, this becomes 0. All zeros, anything multiplied by 0 gives you 0. 0 plus 2 is 2. So the height or the y value at 0 is 2. Now check the second one. So your f of b, the b value is 1. So f of 1 you have to calculate. Put 1 in the equation. So you will get 1 cube minus 3 times 1 is square plus 2 times 1 plus 2 equals 2. And if you will calculate 1 minus 1 is 0. 1 minus 3 is minus 2. Minus 2 plus 2 is 0. 0 plus 2 is 2. So you can see that the height at f of 0 and at f of 1, they are equals to 2, means they are equal to each other. So you can say that the third condition also is fulfilled. Now what you have to do? You have to apply the Rolle's theorem. So what does the Rolle's theorem says? Rolle's theorem says that the derivative is equals to 0. The derivative is equals to 0. Why? Because at certain point C, you will get the slope of tangent line which is equals to 0. So rather than writing the x, I will write the C because the derivative is equal to 0 at that particular point. Not everywhere the derivative is 0. Okay, so derivative at certain point between 0 and 1 will be equals to 0. So we have to calculate that C. So what is the derivative? You already determined that this is your derivative, right? So replace x by the C. So how can we write? We will write here 3c square minus 6c plus 2 equals to 0. Now don't show the work because they are not asking you to show the work. They are asking you to determine the value of C where this derivative is 0 or where the slope of the tangent line is 0. You can use the calculator. Okay, if you have a scientific calculator, go to the mode 53. If you have the another calculator, go to the equation, then press the polynomial, then press the degree 2, and then write the x square, x, and the constant values. Remember, in order to write in the calculators, the first thing you will write the coefficient which is written with the x square. Here you will write the value of the b which is written the coefficient with the x, and here you will write the constant value. So this is our a value, this is our b value, and here is our c value. And don't forget to write with the signs. So the first is 3, so a is 3, b is -6, then again press equal and you will get 2. Now write in the calculator 3 minus 6 and 2, and you will get the two values of x. So the first value is x equals to 1.57, and the second value is x equals to 0.42. Now check which option falls in the closed interval. Okay, we have to read the function between 0 and 1. Okay, we don't have to take the edges. The thing is that if you have any graph, for example here from 0 to 1 over here, okay, let's suppose a value comes as 0. Okay, so on the 0, of course you have to start from here. So on the 0, even if you are reading like that, on the 0, if you are starting, the 0 is not included. Okay, because you cannot make, this is in between, you will find a value where the slope of the tangent line is 0. So you only have to find out the value which is between this interval. So here you can see 0.542 is in between 0 and 1. 1.57 is out of the line. So to understand this concept, also understand, look at this one. So here is 0, okay, here is 1. You have to read only the graph from 0 to 1. Now 0.42 is in between. And where is 1.57? 1.57 is somewhere here which is out of the boundary. So I don't want to take this point. So I will take only 0.42 as my answer. But while solving the question, please write both the values and select the correct one. Let's solve another question. So let's solve another question. So the first thing is you have to check if the function is continuous or not. So you see that x to the power of 2, it is the sign of a polynomial function where the domain is all real numbers. So what is the conclusion? The conclusion is function is continuous on closed interval -2 till 2. Second thing, you have to check if it is differentiable or not. So let's take the derivative. Okay, so the derivative of this function x square, the derivative is 2x, minus 1, the derivative is 0. Now 2x is also a linear function, polynomial function again. So polynomial function, the domain is all real numbers. So what is the conclusion? The conclusion is that the function is differentiable on the open interval -2 till 2. Again and again I am stressing on the on the open and the closed interval. Open why? Open why? Because I don't want to take -2 and 2. I don't want to read or make the slope of the tangent line at these points. I don't need it. I want to make the row according to the Rolle's theorem. You will find the C value in between them. In between them. Not at -2, not at 2. In between them. So make sure that you write the open interval in the continuity, closed interval in the continuity, and open interval in the differentiability. And what is the third point? Check the heights. Okay, check the y values at a point, which is -2, and check the y value at the b point, which is 2. From where I get this point? This is the a value and this is the b value. Okay. So replace into the equations, into the original equation. X is square, so negative 2 whole square. Don't forget to put this bracket. Because if you write minus 2 square, it will give you minus 4. But if you put the brackets, it will give you 4. Minus 1. So negative 2 whole square minus 1, 4 minus 1 gives us 3. Now put the value of f of 2. So f of 2 you will write 2 square minus 1. So again the answer is 3. So what have you seen? That f of negative 2 is equals to f of 2. So hence all the three conditions are fulfilled. We can apply Rolle's theorem. And Rolle's theorem says that at certain value of c, the derivative is, at certain value c, the derivative is equals to 0. Slope of a tangent line is 0. So what is f prime c? We already have known about the derivative. Okay, so derivative is 2x. So rather than writing x, I will write 2c equals to 0. Now divide both sides by the 2 to solve for c. So c equals to 0. So try to understand. Okay, so here is minus 2. At the end is 2. Where does that 0 comes? 0 comes in between. So yes, 0 is our answer. Another question. We can apply the Rolle's theorem in our daily lives example. A small delivery drone flies in a straight line and its height above the ground in meters after t second is modeled by a function which is in front of you, t cube minus 6t square plus 90 for 0 till 3. And the means you can say that the 0 and 3 are included because t is greater than and equal to 0 and less than and equals to 3. So the closed interval is 0 to 3. After 3 seconds, the drone is at the same height as when it started. So it is already saying that f of 0 equals to f of 3. But we have to check the hypothesis because they are saying verify that function satisfies the conditions of the Rolle's theorem on the interval 0 of 3 and then find the value of the c. Okay, so let's try to understand. So what is our first condition? Check the continuity. Again, it's a t cube minus 60 square plus 90. It is a polynomial function. Polynomial function's domain is all real numbers. So what you will say? That it is continuous on closed interval 0 to 3. Now second thing, take the derivative. Okay, so h prime of t. The derivative, if you take, bring the 3 over here, write the t from the power, subtract 1, it's 3t square, minus multiply 2 times 6 is 12, t from the power we subtract 1, so 12t plus derivative of 90 is 9. Again, is this a polynomial function? Means it's continuous, okay? Means that it is differentiable or its domain is negative infinity till positive infinity. So what is the conclusion? That the function is also differentiable. But don't write only differentiable, differentiable on open interval 0 and 3. Now third thing, you have to check what is the value of at 0 and what is the value at 3. So the height at 0, replace t by 0. So 0 cube minus 6 times 0 square plus 9 times 0. If you write in the calculator, you will get 0. Similarly, put 3 cube minus 6 times 3 square plus 9 times 3. Write in the calculator, get the value of height, which is also 0. So what have you concluded? That the height at 0 is equals to the height at 3 point. So it means that all the three conditions are fulfilled. So let's apply the Rolle's theorem. So we can say that at certain point, C, the derivative is equals to 0. And write the derivative in terms of C. So 3C squared minus 12C plus 9 equals to 0. Now to solve for the C, we will go to the mode 5.3 or to the calculator to factor the quadratic equation. So you will write in the calculator 3, negative 12 and 9. Those who want to do it manually also can do the manually. So the x value is x equals to 3 and xc equals to 3 and c equals to 1. Now have a look over here. You have to say, according to Rolle's theorem, between 0 and 3, whatever the value comes, there you have to make the tangent line and there the slope will be equal to 0. So here this is at 3, but 3 is at the edge. In our condition, 3 is included, but no need to make the slope of the tangent line at 3. You have only to take the value which is between 0 and 3. So the correct answer will be 1, not the 3. Remember this thing because you are not reading the whole graph. Maybe the whole graph is like that, okay? So maybe the whole graph is here. Here this point is 1 and this point is 3. But we are reading only this part of the graph, So of course, if this part is erased, see, if this part is erased from the screen, then how can at this 3 point you will have the tangent line equals to 0, right? So that's why we don't take the edges. We only take the middle part where the C is or the slope of the tangent line is 0. Let's solve another question to avoid any kind of the misconception. So the first point is check what is the name of the function. It's polynomial function. What is the domain of a polynomial function? Is all real numbers. So if it is all real numbers, then it means definitely it will be continuous on -3 till -1. Second part, take the derivative of the given function. So the derivative of the function is 2x plus 4. This again is a linear function, a polynomial function. The domain is all real number. So the conclusion is that this is also differentiable, but differentiable on open interval -3 till -1. Sorry. So now the third point is check the y values at the a point, which is -3, and also at the b point, which is -1. Put -3 in the original question. So -3 is square plus 4 times -3 plus 5. So write in the calculators, 3 times 3 is 9, 9 minus 12 is -3, -3 plus 5 is 2. Okay, check the second one. Okay, put -1 in the question. So -1 whole is square plus 4 times -1 plus 5 equals. So -1 is square is 1, 1 plus 4 is 3, minus 3 plus 5 gives us also 2. So you can say that at f of a equals to f of b, or f of -3 equals to f of -1. So the first part is that you already have checked that yes, the Rolle's theorem can be applied. So now what does Rolle's theorem says? That at certain point of C, where the derivative or the slope of the tangent line is 0. So now you have the derivative over here. Write it in terms of C. 2c plus 4 equals to 0. It's a linear function, so bring the 4 here, gives you -4 2c equals to negative 4. Divide both sides by the 2. So c equals to negative 2. Now check if you can understand that negative 2 falls between negative 3 and negative 1 or not. So here it is negative 1 and over here is negative 2 and then comes negative 3. So yes, negative 2 falls between negative 3 and negative 1. So this is our answer. Now I would suggest that before watching the video, just pause the video and solve the question yourself. And then check that if your answer and my answers are same or not. So here what you have to do, the first thing is just check. Okay, so the first thing is that the function is polynomial. So if the function is polynomial, our conclusion is that the function is continuous in the closed interval negative 1 and 2. Now for the second condition, take the derivative of the function. So the derivative is, bring the 3 here, x from the power subtract 1, so 3x square, minus multiply 2 by 2, that is 4x from the power subtract 1, so 4x, minus derivative of x is 1 and minus 1, derivative of 1 is 0, so no need to write it. Again, this derivative is actually the polynomial quadratic function. Domain is all real numbers, so you can conclude that the function is differentiable in open interval. In open interval, I am stressing on the closed and the open interval again and again so that while solving the questions you don't make the mistakes. So now what is the third condition? Check if the functions y value at the a and the last b point are similar or not. So our a value is negative 1, which is our starting value, and the b is 2. Substitute negative 1 in the original question, okay, and check what do you get it. Okay, so negative 1 power 3 gives us negative 1. Negative 1 power 2 gives us 1. 1 multiplied by minus 2 is minus 2. So minus 2 minus 1 is minus 3. And here positive 1 and negative 1 cancel out. So the answer is negative 3. Similarly, you can use the calculator to calculate all these stuff, okay, to make sure that you are not making any mistake. Now, what you have to do, put the 2 in the question. Minus 2, 2 square, minus, then again 2, and then minus 1. If you will check, it will also give you the negative 3. So what is the conclusion? That f of negative 1 and f of 2 are equals to each other. So now you can apply the hypothesis of, you can apply the Rolle's theorem. The Rolle's theorem says that in between negative 1 and 2, there is a C point where the slope of the tangent line is 0. Means write the derivative in terms of C here. Rather than x, I am writing here C. 3c square minus 4c minus 1 equals to 0. Now factor them. Use your calculator to factor fast. Okay, so go to the mode 5-3 or go to the equation polynomial degree 2 and write the a, b and c value. So a is 3, then b is minus 4 and the c is negative 1. And what do you get? Write in the decimal form to understand whether it falls or it doesn't fall in the open interval. So C value is 1.54 and the second C value is negative 0.21. Now understand if both are the answer or only one is our answer. Okay, so for that I am just showing you by a number line. So our first point, the initial point is negative 1 from the closed interval and the last point is 2. Now here is our 0 somewhere in between, right? Now where is 1.54? 1.54 is somewhere here, right? 1.54, yani in between 0 and 2. Now where is 0.21? 0.21 with the negative sign is somewhere here. So you see between -1 and 2, both the C values fall. So it means both are our answers. So if you have problem in understanding which C value you have to take, you make a number line, put over here the first point of the closed interval, put at the end the second point of the closed interval, and then check where is our C value. The C value should fall between the initial and the final points of the given closed intervals. So last question, let's check one more time. Again, the equation, the function is polynomial, domain is all real number, conclusion is continuous in closed interval -1 and 4. Second thing, take derivative of the function. The derivative of x cube is 3x square minus derivative is of 4x square is 8x minus derivative of x is 1 plus 7, derivative is 0, so stop it over here. This is also a polynomial function. If it is polynomial, domain is all real number, the conclusion is differentiable, but differentiability should be in the open interval. Now the third point, check what is the y value at the A and at the B point. So calculate f of -1 and calculate f of 4. So replace -1 in your original question. Okay, and carefully write all the signs to avoid any mistake. So you will get here 3. Right now 4 in your original question. So 4 cube minus 4 square minus 4 plus 7. Write in the calculator and you will again get 3. So what do you get? That f of -1 and f of 4 are equals to each other. Now what does the Rolle's theorem says? That in between negative and 4 there must be a C value where the derivative is equals to 0 or the slope of tangent line is 0. So here is our derivative. Rather than x, replaced by the c. So 3c square minus 8c minus 1 equals to 0. Now factor them. In order to factor, what we will write? A and B and C values. So A is 3 equals B is -8 equals C is -1. So what two values do you get? Write in the decimal form to understand if it is falling in between the interval or not. So C equals to 2.78 and another C is equals to -0.11. So let me check if I have done correctly. So it is 3 minus 8 minus 1. And yes, the values are 2.78 and value is -0.11. Now check with the help of a number line. Okay, here is the number line. So the first point A and here B. Okay, so the A is -1, B is 4. Now somewhere here it is 0, right? Okay, 2.78, definitely 1, then 2, and here should be somewhere 2.78. So yes, 2.78 false. -0.11, so on this side all negative numbers. So here -0.11 somewhere. So both the values are correct. So both are your answers. Now I hope that this concept is clear to you. And we have practiced more than enough questions in this video, and we'll see other functions later on in other video. Thank you very much. In the next video we will study and we will meet again with another topic.